Now in blue here, all the samples today will be in a different font and in blue. There's a lot of text on the screen. I tried to make it stand out as best I could. So as we can see here, now we're at 9%. If you look at the bottom of the page, I've got, and these are ballpark figures, but I've got the job progress pretty well mapped out. So for the first 5%, we're connecting to the host. We're looking to see if we can find that old staging disk, and through that, determining if this should be a full or an incremental job. 5 to 9%, we're checking the existing mounts on the host. Now, if this is a VM and the mounts are disks that are in independent mode, those won't be snapped. So we'll either clean the mounts or we just exclude them, and then we'll start connecting the staging disk to the host. Now at that 5 to 9, maybe up to 12%, that's when you'd be able to go into your disk management services in Windows or FS tab in Linux, and you'd be able to see that mount point appear. Now at 9 to 14, that's when we validate host connectivity. Now when that test completes, when we say, are you there and can you connect to the host? As soon as the host Rogers or says yes, that's when you see these entries pop up in your host operating system. So from 14 to between 88 and 95%, we're just writing data. Now, if you want to kind of see how things were going along, two things you want to look for is progress and status. And as you can see in my example above, if you search for progress, that 9, it is what you think it is. It's 9%. So we can actually track what's going on. So your environment, the way your things work, the percentages that I've put on the bottom may be a bit different. They are somewhat contextual. However, if you look for progress, you can then identify in your environment what your environment is doing at these certain percentage points. Like I said, these are a rough ballpark. We should be pretty close, but your knowledge of your own environment and the context in which the jobs progress through your infrastructure might be just a little different. And you can determine that by just really checking progress and status just to see what the CDS is doing with the host at a certain completion point. All right, a little bit more on writing to the staging disk. And now this is, we were just looking at the UDP PM log or UDP log. We are now looking at the exact same operations that we just talked about, but we're looking at it from the UDS agent log. So again, a lot of you have seen these UDS agent logs. Some of this may be familiar, but this is the corresponding messaging in the UDS agent for what we just saw in UDP. So we can see the connection from host. There are a couple of places where I had to put in variables like host name or IP address. Clearly that's going to be a DNS name or something. And yes, the IP addresses are made up and edited after the fact. So as we can see here, we can look for the job number, just like we did in the UDP PM log or UDP log. And we can find where the UDP service has reached out to the UDS agent service, verify connection. Now, here's the more important part. The one log that you will be able to tail or interact with as the log is writing is the UDS agent log on the host. All of these root level logs that we've downloaded, they all get stopped and then downloaded. Obviously, they're not continuing to write while they're on your desktop. However, the UDS agent log in your host, you can tail and you can watch it real time to see exactly what's going on. The important thing to search for here is worker thread and then the job number. So we're just going to append worker underscore thread underscore, and I've got that spelled out in the top here, to the job number that we've been searching for all along. And as we can see here, we show it at 24.5%, and there's some good metrics in here too. It shows us how many gigabytes we've read out of how many total, and then how many copied. It gives you our throughput in megabits per second, and then we'll tell you the total amount of files. Now in this case, where you see the ellipses, I've chopped out some log. Really, this just counts 24, 25, and so on. This was an error-free job and completed, and we had a good snapshot. Now we're going to talk about what we might see, what we would search for, and what we might do if we did not just have a successful snapshot. Now the UDP or UDP PM log is probably going to be the most useful log to look at when you're trying to troubleshoot these sorts of things. There's a whole pick list here. Depending on what you're trying to sort out, there are different things you're going to want to look for. If you're just looking for progress, or you're just trying to do some investigations for automation planning, job number is still going to be the right way to go. If you're trying to look into a failure, that's what the rest of these are for. So we've got error code, and now that is intentionally ERR code, error, fail, terminated. Now terminated could be good or bad. Whenever we complete a job, we terminate it. So if all you want to do is find the end of the job, just look for terminated, and whether it ended in success or failure, keying in on that terminated word is going to bring you to the end of that portion of the logging. You can also take the error output right from the UI. So example here, job failed with error 5017. Now that one little one-liner that you get on your UI may not be all that helpful. However, if we search error 51 or 5017 in the logs, we would also see a notation that said unauthorized user access. So in this case, the failure with an error code of 5017 was a failure resulting from somebody trying to use a user account, an LDAP account, a domain account, to contact a host with the wrong username, the wrong password. It's somehow the credentials are bad. So your UI is going to show you job failed with error 5017. If you then went and found the portion of the logging that captures that job by searching the job number, and then search that 5017, then you will see the context that it was an unauthorized user, and that would tell you that there's a permissions-based issue going on. It's not connection-based. Maybe somebody just mistyped the credentials when they were setting up access to that host in our UI. So generally anything that has a warn log level, and we use standard Linux log levels, just info, warn, severe. We generally don't see a lot of severe. Generally things are caught by the warn level, but you can search for warn. It will generally be as verbose an output as searching for something like error. But if you're really just trying to cast a wide net so you can start then narrowing down on what you found, just looking at the warn log level is a great place to start. Cancel is another good search term. Works similar to terminated. However, you will never see a cancellation after a job success. So if you manually cancel the job, you'll of course see a cancellation. If we're trying to connect to a host, we'll try 5 times to exercise the multipath policies. If after 5 iterations of the multipath policies, we still can't connect with that host, we will move on and do something else. Now, after the 5th time, we automatically issue a cancellation, which works in the same way that you canceling a job manually from the UI works. So if it's a connection issue, and maybe it was a connection issue, maybe it wasn't, if you see the job end with cancel, look in the 10 to 15 log lines preceding that, look for those 5 retries, and that would help you identify a connectivity issue. Now, here are some examples of some of the things we just talked about and how using those keywords will really drive you right to the important parts of the logs. So here we're looking at the warn log level, and we've searched for error. We can see VM task has failed, virtual disk is either corrupted or not in a supported format. Now, in this case, we actually just couldn't talk to the storage. So in between these two, you'll see the ellipses and retries. We'll go through this 4 or 5 times, and then you can see the VM task failed. What was the VM task? What were you trying to do? That is in that second log example in the top line. And you can see add raw device mappings, add RDM request failed. So we really didn't have a corrupted or unsupported vdisk. What happened is we made a mount or a mapping request and we couldn't map it. In this case, it was because of a connectivity issue. And then the next log snippet down shows the cancellation, the automated cancellation, and the cleanup around it. So if you have a snapshot and you have not deduplicated it, and you have not replicated it, we will not expire it. In the same way, if your follow-on snapshot does not succeed, even if your retention date for the previous snapshot has passed, we will hold on to it until we get another good snap. So as you can see here, not expiring, the very bottom line, not expiring image ID. It is the last backup image, and application, app name is still under protection. So we couldn't get you a new snap. We don't want to get rid of your old snap. We want to make sure that you can restore some level of that data. Now, similar event logs from the UDS agent. So again, that was UDP PM. We have corresponding events in UDS agent. UDS agent, again, the key search terms are going to be job number, error code, failed, terminated, the error output from the UI, or the warn log level. Almost one-to-one identical to UDP at this point, where we're trying to really troubleshoot a failure or some sort of issue in onboarding new applications. So as you can see, all these of the things that I've suggested, I have brought all of the search terms that would have been hits in your grep or your find statement. So here we can see that we failed to open a file, and maybe we're not real network savvy, And we don't necessarily know what query iSCSI adapters might mean. Maybe we're not network admins. If we scroll down, we have a little bit more, error code 5017. So what had happened in this example is the protection policy was set up with a user account that didn't have access to the storage that this SQL host was using. So when I tried to use those credentials to access this storage, we reported we can't get a disk. And if you look at all these error messages, this looks like it could be a network issue. The way we kind of call it out, we say that we can't find an initiator name. Now, the initiator name actually does live in that folder in the initiator name.iSCSI. The problem is the user that we used does not have permission to see into that folder. Therefore, the job cannot see into that folder. We can't find vdisks, and it looks a lot like network issues. The notifying quit event, error code, there it is, ERRCODE, 5017. That 5017 would have been the key to tell you it actually isn't a network problem. This is an access problem. This person does not have permission to utilize that iSCSI path. Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.